when we select a pump, we try to get our duty point in a preferred operating zone. And that preferred operating zone is either side of the best efficiency point on the pump curve. So here we have a pump curve, and here we have the best efficiency point. So our duty ideally should fit in that area where it's a safe zone for us to operate the pump. But because we select pumps from a range, sometimes we're not able to select a pump that's operating really close to its best efficiency point, so we have to make compromises. But what I want you to understand is that by making compromises in sizing the pump, there are some prices to be paid, and that depends how close you are operating to best efficiency point. If you move to the left of best efficiency point, you might start to run into discharge recirculation, which is recirculation of the fluid in the discharge area. As you go further back down the curve, you can get suction recirculation, which is recirculating the fluid in the suction eye of the impeller. As you go further back, you can get reduced bearing and seal life because you start to get vibrations and greater deflection. And then in the final analysis, you can go into low flow conditions, which could cause cavitation and temperature rise within the casing. And obviously, you can see that as we move away from best efficiency point, we start to get a lot of unpleasant things happening with the pump. So we don't want to be operating in this zone. This zone will reduce the pump life, and this zone we need to avoid. If we go to the right of best efficiency point, we can run into problems with cavitation due to the high NPSH required by the pump at that point. And that cavitation can give rise to very unstable operation, high power loads and vibrations, and possible component failure.